So 131 was another solving. Ooh, a little bit longer here. So it's, sorry, 1 over x squared minus 3x plus 2 equals 1 over x plus 2 plus 5 over x squared minus 4. Okay, before you jump right into getting a common denominator and saying, oh, this needs an x plus 2 and it needs an x squared minus 4, you definitely want to factor first, because it may already have some of those, they're just hidden. So this would factor into x minus 2, x minus 1. This one is just its x plus 2, and this one is x minus 2, x plus 2. Now if you look at that, this one's really only missing the x plus 2. So I give it an x plus 2 over x plus 2. This one is missing x minus 2 and x minus 1. So I've got to give that to the top and the bottom. And then this one is just missing an x minus 1. And it's easy to make a mistake in that part, so I always get in the habit of doing x minus 2, x minus 1, x plus 2, x minus 2, x minus 1, x plus 2, x minus 2, x minus 1, x plus 2. So that they all match, and I can just drop them and solve the top. So 1 times x plus 2 is just x plus 2. FOIL here, I get x squared minus 1x minus 2x is going to be minus 3x, and negative 2 times negative 1 is going to be plus 2, plus 5 distributed to the x minus 1, 5x minus 5. It's a quadratic. I'm going to subtract this x over and subtract this 2 over, get it equal to 0, and I have x squared, negative 4x plus 5x is going to be plus 1x. Got all that accounted for. And then the 2 minus 2 is going to cancel, so I just have minus 5. And if I can solve it using factoring, good. If I can't, quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. A is just 1 there. And then I'm just going to get my 2 answers once I crunch this down. Okay, so negative 1 plus or minus 1 plus 20, right? Negative 4 times negative 5 is 1 plus 20, so 21 over 2. And those are your 2 answers. That's really all we can do. 21 doesn't break down any further. And the only excluded values were 2, 1, and negative 2, which that's not going to equal. Those are nice numbers that are excluded values. I didn't get that anyway, so I don't need to reject that. So in a quadratic, if you have to jump in the quadratic formula, just go ahead and do it. Don't delay. Don't sit and sulk and feel bad for yourself. Just get it done. And then 135 was, oh, I had a bunch of questions on this one. What am I dealing with here? 2x squared plus 4x minus 9. The directions are, list all numbers that must be excluded from the domain of each rational expression. So the only numbers that need to be excluded from the domain are ones that make the denominator 0, right? So 2x squared plus 4x minus 9 cannot equal 0, essentially. And I just have to pretty much solve what x cannot equal, which will look identical, except for I'll have it a little slash through the equal sign. Is this factorable? Are there 2 numbers that multiply to get negative 18 that add to get 4? 1 and 18, 2 and 9, 3 and 6. That's a no, right? So just the quadratic formula. X cannot equal negative b plus or minus the square root of b squared, which is 16, minus 4 times a times c, all over 2 times a is 4 in this case. So I have negative 4 plus or minus the square root of, now this is 8 times 9 is 72, so that's a plus 72 because there's 2 negatives. 16 plus 72, 82, 88 over 4. 8 can be reduced into root 4, root 22, yes? So that's going to be negative 4 plus or minus 2 root 22 over 4. And because this term, this term and this term all can be reduced by 2, I can reduce the fraction everything by 2. So that'll be negative 2 plus or minus 1 root 22, which you don't really need the 1, over 2.